Hello, once again. Welcome to our next series on hypothesis testing. And it's going to sound eerily familiar if you listen to the previous section on testing for proportions, because broadly speaking, very little changes from test to test to test. The only thing that changes is the test statistic you're using, because it's a different distribution, and the appropriate p-value or the appropriate critical value, however you're doing your test, will change based on that distribution as well. And I'll show you what I mean here in this section about hypothesis testing for means. So for this unit, we're going to start to rely more and more on calculators or online calculators or online apps or things like that, just because you can use a z-table to get p-values pretty effectively, but it gets very difficult to test against get a p-value off a t-distribution, or to get a p-value off of a chi-squared distribution, which we'll work with a little bit in the next section. Everything else, though, should be the same as all the other forms of hypothesis testing. You're going to have a claim. You're going to make some testable hypothesis. You're going to decide on your significance level. Once you've decided on your level for alpha, you will then get sample data, get a p-value. Well, the p-value part's optional, but either way. And you'll make a decision based on your sample data that either rejects your null hypothesis or fails to reject the null hypothesis. And more often than not, unless you claim equality, right? Unless you claim equality, your null hypothesis, if rejected, makes you support your claim. But either way, whether you're making a claim for equality or inequality, you will be able to reject the null hypothesis, giving you something definitive to say, or that won't happen. That's what's going to happen here. So for just a quick start guide here, when you're making a testable hypothesis, always remember this. The null hypothesis is equals number. So for here, we're talking about means. So we're hypothesizing that the mean equals a number. So the mean grade for a test might be 70%. So then H0B equals 70. And the alternate hypothesis marries the null hypothesis to what you claimed in some way. So if you claimed it was above 70%, you would use the greater than symbol. If it was claimed to be less than 70%, you'd use the less than symbol. And of course, if you claimed equality, then because it has to be different, you'll use the not equals to symbol. Also, something to think about: decide on alpha before you find a p-value so you don't get into the issue of confirmation bias. And finally, the way we'll do test statistics in this section is either going to be z, so a z-score again, if you know your population standard deviation. Broadly speaking, you will not know the population standard deviation. It's quite rare for you to know that in advance. So more often than not, you will find yourself using this test statistic here, which is the t-value off of the student t-test, and we will use technology as appropriate for that. So yeah, that pretty much never happens. But if it did happen, right, if you did know the standard deviation for the whole population, then you get the test statistic z, and you'd pretty much do what we did in the previous video series. But because I'm assuming you got to this point knowing how to do that, we will go forward with just focusing on the t-value here. So here's how I'm going to end this video. I've got 3 different claims, and I want you to make the null hypothesis and the alternate hypothesis for each of those. We'll see it in the next video. So the first claim here reads that the mean magnitude for recorded earthquakes is less than 3.0. The next claim is that the average U.S. male adult weighs more than 75 pounds. And finally, the mean body temperature for adults is 98.3 degrees Fahrenheit. So come up with H0 and H1 or HA, and I'll see you in the next video.